All right, hey geometry students, it's Mrs. Fellon. I'm on lesson 6.1, page 166 of your student journals. All right, so we're going to talk through a few theorems here before we get into some practice problems. So the first thing I want to talk about first is a vocab word, and it's this word equidistant. So the word equidistant means equal distance. Kind of sounds like the same way that you would say it, right? But it means that it's the same distance away from something. So if you said, these 2 points are equidistant from the line segment, it means that they're the same distance away. The next thing I want to talk about is this perpendicular bisector theorem. And so it says, in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So basically what we're getting at here is if we have a triangle and we have this line right here, and we know perpendicular bisector. So remember, the words perpendicular bisector implies that it's not only perpendicular, so it meets at a right angle, but it also bisects the segment. So what you're going to notice is that it cuts it into 2 equal parts. If that's true, then C to A is equal to C to B. So like this distance and this distance would be the same. And so if we know this is a perpendicular bisector, then those 2 line segments must be equal in length. All right, the converse of the perpendicular bisector theorem states, in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of a segment. So again, if we're talking about the fact that we know that D is the same distance from B as it is from A, so those 2 segments are congruent, then we know that it lies on the perpendicular bisector. So then this must be the perpendicular bisector. So it's just basically, like we said before, the converse of that theorem. Turn to page 167. Let's talk through some problems here on page 167. Angle bisector theorem, similar. And so again, remember, an angle bisector basically bisects an angle, right? Cuts it in 2 equal parts. So if a point lies on the bisector of an angle, then it is equal distance from the 2 sides of the angle. So let's pick point D, for example. It lies on the angle bisector of this angle. Then it is equal distant from both sides of that angle. So those 2 pieces must be equal. All right. And then the converse is, again, kind of, obviously stating the opposite. If we know that D is equal distance from B and D is equidistant from C, then this must be the angle bisector of the angle. All right, what we're going to do next is I am going to kind of walk us through some, just some practice problems real quick. And then a lot of what you're going to be doing is you're probably going to be doing a lot of this in class. Some of this is very, very simple, and you're going to find this to be, not too challenging for yourselves. Let's start by drawing some diagrams. We're going to start by drawing a triangle. I'm going to give you this information. So this might be an example problem, and it might ask us to find the distance from P to R. So when we ask to find the distance from P to R, what we're asking for is this whole length here. And so what we're looking at is if you notice, this is perpendicular and those 2 sides are equal in length, so they're congruent, which means that this has to be the perpendicular bisector of the triangle. And so what we know is that this segment right here, then, since this has to be the perpendicular bisector, that means this piece here, P to Q, is 5, and therefore R to Q has to be 5, which makes P to R 10. All right, let's do another example. This time I am going to draw a triangle that looks like this. This is H, E, G, F. So our goal is to find the distance from G to H. Remember, we're asking, when we do this terminology, when I write the letters like this means you're finding the distance from point G to point H. We're not doing like the line segment or anything. So just understand that what we're asking you to find. So what I'm asking you to find is this length right here, G to H. So if we know this is the perpendicular bisector, and I forgot to mark one thing, and so we do know that it bisects it and we know it's perpendicular, then this means this line segment and this line segment have to be equal. So the only thing I need to do here is set those two pieces equal to each other. And then let's solve for x. All right, be careful that you're not actually stopping here, because it did ask us to find the distance from G to H. So now we need to go back here and plug in 3 times 8 minus 8. So that would be 24 minus 8, which is 16. So the distance from G to H would indeed be 16. All right, the last example I'm going to work through is going to be a little bit of a word problem, so you can write this down. Write an equation of a perpendicular bisector. So it says write an equation of the perpendicular bisector of the segment with endpoints, and I'll give you D is 5, -1, and E is the point -11, 3. Right, so what we're asking you to do here is to write an equation of the perpendicular bisector. So we're asking you to find the equation of the line. So basically what I'm asking you to do is, like, if you were to graph this, find like since this is a straight line, you would find like the y equals mx plus b, the equation of that linear line. So in order to do this, the first thing we're going to do is find the midpoint. So we're going to do the midpoint of DE. So remember, to do the midpoint, you add up your x's and divide by 2, and then add up your y's and divide by 2. So I get -3, what looks like to be 1. So that's step 1, find the midpoint of your line segment. Because we're going to write the equation of the line, so it says we want the perpendicular bisector of the segment with the endpoints of 5, -1, and -11, 3. So we're going to find the slope of D to E, because we need to figure out the equation, so we need to figure out the slope. So remember, we're going to do y2 minus y1 over x2 minus x1. That's your equation for slope. And so I'm going to get 3 minus a -1, which is 3 plus 1, over -11 minus 5. I get 4 over -16, or -1/4. All right, so imagine you have this line segment D to E, right? So here's D, here's E. You want the equation of the perpendicular bisector. Well, you don't want the slope of DE. You want in relationship, you want to know that this line here, that's the perpendicular bisector, has to be perpendicular to this one, right? So we want to now find the perpendicular slope. So all that means is that we're going to take this slope, this -1/4, and we're going to take the opposite reciprocal, which in this case is 4. So now we figured out this midpoint was -3, 1. We know the perpendicular slope is 4. So now what we can do is we can write the equation of our line. And we can go y minus y1 equals mx minus x1. And so I'm going to plug in my midpoint, which is the point -3, 1. I'm going to plug in my slope, my perpendicular slope. And I'm going to solve. So I get y minus 1 equals 4x plus 12. I get y to equal 4x plus 13. So that is the equation of my perpendicular bisector of the line segment DE. All right, so that should kind of walk you through kind of how to do each type of problem that you're going to see. What I would recommend is that you try the practice on big ideas, and then if you have any questions, bring them to class. All right, thanks guys.